I'll begin with a brief summary of the business opportunity driving our project. Our retail business has faced consistent challenges with inventory planning because of seasonal swings and fluctuating demand. When we understock, we lose revenue and disappoint customers. But when we overstock, we take on extra storage costs and reduce profitability. So improving demand visibility is essential to balancing product availability and operational efficiency. To solve this, we propose implementing a retail demand forecasting system. We use monthly sales data for our 5 core products: t-shirts, jeans, hoodies, sneakers, and jackets. Using this historical data, we aim to produce accurate Year 3 demand forecasts to guide smarter purchasing and inventory planning. The purpose of this project is to analyze 2 years of sales data from January 2023 to December 2024 and use it to predict monthly demand for the upcoming year. Along the way, we look for seasonal patterns and trends that can help us optimize stock levels during both high and low demand periods. A data-driven forecasting approach allows us to reduce stockouts during peak seasons, avoid unnecessary overstock, and improve overall customer satisfaction. This ultimately helps increase profitability and supports more confident, proactive planning. Our dataset is stimulated and tracked over a 24-month period for our 5 retail items at fixed points. Variables included are month, units sold per product, and total monthly revenue. This structure lets us evaluate product level performance as well as overall revenue trends. Our dataset contains 120 records. This comes from 5 products tracked over 24 months. Here we have included a brief summary table of what our dataset equates to. So we have our 5 products, the total units sold throughout the 2 years, and some trend observation. T-shirts had a steady growth and they peaked in summer. Jeans were steady and consistent all year round. Hoodies had a strong winter demand. Sneakers have a slight rising upward trend, and jackets as well had a strong winter seasonal demand. Before analyzing the data, we performed several cleaning and validation steps. We verified that there are no missing or duplicate entries, and we checked that month labels were consistent. We also confirmed that product prices stayed the same across all months and recalculated revenue fields when needed to make sure totals matched correctly. Additionally, we ensured every product appeared in all 24 months so our forecasting model would not have gaps. There are also a few limitations to keep in mind. The data is stimulated rather than based on real customer behavior. It doesn't include external factors such as promotions, holiday effects, or advertising. Prices are assumed consistent, which simplifies reality. And finally, we only have 2 years of historical data, which limits our ability to detect long-term trends. Even with those limitations, we were able to detect clear seasonal patterns. Jackets and hoodies show strong peaks between October and February, which aligns with colder weather demand. T-shirts peak from April through August, reflecting warm weather buying. Sneakers show a mild upward trend over the 2 years, indicating steady growth, and jeans remain consistent in demand throughout the entire year. Lastly, we observed moderate year-over-year growth. Total revenue increased from $673,820 in year 1 to $693,320 in year 2, which represents a 2.9% year-over-year growth rate. This upward trend supports the need for more accurate forecasting as our customer base and sales volume continue to expand.
Visually analyzing the historic sales data revealed a linear trend with seasonality. Sales are at their peak in December and fall throughout the spring, hitting a low for revenue in the summer months. Sales of jackets and hoodies are highly correlated, and the sales of t-shirts and sneakers follow a similar off-season pattern. Jeans sales remain steady throughout the year. T-shirts are the highest selling product, followed by jeans. Jackets are the lowest selling item. Sales appear evenly distributed among the 5 product categories. Looking at the sales data with descriptive analytics reveals that December is the highest selling month each year, while June is the month with the lowest sales. Average monthly sales for 2024 were $57,777, and annual sales totaled $688,920. T-shirts are the most frequently sold item, although they are the lowest priced at $20, and so t-shirt sales account for about 10% of total revenue. Jackets, on the other hand, make up 16.78% of sales by unit and 27.7% of total revenue. Examining the percent change from year to year shows that hoodies are the product category with the most growth, while jacket sales have declined slightly. Using the months as dummy variables and performing linear regression analysis on each of the products sold allowed us to create a forecast for the following year of sales for each of the available products. This can help us not only make forecasts for stocking, but we can use this data in strategic and operations planning.
Based on the analysis of our data, the company should take on a data-driven retail forecasting system to navigate product allocation, inventory ordering, and strategic planning. By combining linear regression forecasts, trend patterns, and product-level performance metrics, the company can securely make crucial inventory decisions to reflect real consumer demand instead of relying on intuition alone. The first thing we highly recommend is to increase inventory on consistent high-volume products like t-shirts and jeans, since they are the products that bring in the most steady sales throughout the year and are the 2 most frequently purchased products. Making sure these products are always available will reduce loss of sales and improve customer satisfaction. Since jackets and hoodies experience the same noticeable peaks around the same time, the company should go ahead and stock up months before winter starts and use demand forecasts to avoid buying excess stock during the warmer months. This seasonal planning will help minimize carrying costs, reduce waste, and enhance cash flow. We also recommend using forecast monthly sales projections to line up with labor scheduling and advertising timing with demand cycles. Advertising should be executed during slower months like during early June to increase sales, while premium pricing or bundle deals can be used during high peak months to increase revenue. By taking advantage of the colder months by promoting deals on the 2 most sold products, the company can sell more units and not worry about having excess stock. By implementing a forecasting-based strategy, this will successfully improve performance by enhancing operational efficiency through smarter advertising decisions, reducing inventory costs by ordering using projected demand, preventing stockouts by purchasing enough products, increasing revenue through improved product availability of high-demand products, and better customer experience by guaranteeing the most popular products are always available for purchase.
Now that you have seen our demand forecasting idea and the data behind it, I'm going to walk through how we would actually implement it. We structured the rollout into 5 phases over about 4 to 5 months. Phase 1 is planning and requirements in week 1 and 2. Here, we lock in the goals of the project like reducing stockouts and overstock for our top 5 products, and we confirm the scope and success metrics. For example, we would agree on targets for forecast accuracy and improvements in inventory performance. Phase 2 is data pipeline and infrastructure in weeks 3 to 6. In this phase, we centralize monthly sales data into one place and make sure it is always in a consistent format. The idea is that the data looks like the clean data set we use in our analysis, but updated every month automatically instead of manually. Phase 3 is forecast model development. In weeks 7 to 10, we build and test forecasting models for each of the 5 products using the historical data. We would back test our prior months to make sure the model captures trends and seasonality and adjust it until the accuracy is acceptable. Phase 4 is the pilot and inventory integration in weeks 11 to 14. Here, we start using the forecast output to make order recommendations for a small group like one region or a few stores. We compare recommended orders to actual demand and fine-tune safety stock rules. Finally, Phase 5 is full rollout and continuous improvement in weeks 15 to 20. At this point, the process becomes part of normal operations, and we review performance regularly to update the models as products or demand patterns change. For data infrastructure, we are intentionally keeping the first version lightweight. We would start with a shared Excel file or a simple database that stores monthly sales for each of the top 5 products. An automated export from the point of sale or sales system would feed the central file every month, so analysts are not rebuilding the dataset by hand. On top of that, we would apply standard data checks for missing values, pricing issues, and revenue calculations so that input is clean and reliable. For tools, we can use Excel or Google Sheets to do the data cleaning and build the initial forecasting logic. We can also use a business intelligence tools like Power BI or Tableau to create simple dashboards that show trends, forecast, and any potential stockouts or overstock risk for upcoming months. The output is a monthly forecast report that translates demand into suggested order quantities and simple alerts for months where projected demand is high. Implementing this solution also requires clear ownership across teams. We would have a project sponsor, typically an operations or supply chain leader, who sets the goals and approves changes to ordering processes. A project manager or business analyst coordinates the phases, manages the timeline, and connects the technical work with business needs. The data and analytics role designs the data model, builds the forecasting logic, and maintains the reports. IT, or data infrastructure, supports them by setting up shared storage and automating data feeds from the source systems. Merchandising and inventory planning are the main users of the forecast. They use the recommended quantities to place orders and adjust safety stock based on their experience. Finally, store operations or frontline managers provide feedback on what they are seeing on the ground. Their input helps explain any gaps between forecast and reality and drives continuous improvement.
The first possible risk associated with our proposed project is data quality issues. Even though the presented data set is clean, future data sales may be inconsistent due to entry errors, missing records, or mismatched product categories. If poor data quality were to occur, then it would result in incorrect insights and lead to untrusted recommendations. The mitigation strategy to address this possible risk is to apply standardized data entry procedures and frequent data audits to secure consistency. Using automated data collection tools would also help to reduce human error. Setting up monthly data validation checklists before analysis begins would also help greatly. The second risk is operational resistance to data-driven decision-making. Managers or employees who are used to making intuition-based decisions through past experience may be reluctant to rely on analytics for ordering, pricing, or advertising. The mitigation strategy for this is to provide necessary training to show how to use these tools and how they can make things simpler for the company. Revealing the results from using these tools to employees will make them see that it can be trusted and they should continue using these tools. Once employees see how easy it is to use these tools, they will feel confident to continue using these helpful tools. The third risk, technology and integration challenges. If the company lacks powerful digital tools or system integration, implementing dashboards, automated reports, or forecasting models may be a hassle to do. This could delay efficiency or result in fresher workflows. The mitigation strategy for this is to starting off with an easy software solution like Google Sheets or Excel-based dashboards, tracking before ascending to additional enhanced tools. Develop a clear process to keep up with updates and support data systems. Assign a trustworthy and reliable employee who can be responsible for system oversight. By addressing these three top possible risks, the organization can positively apply a data-driven decision-making system that enhances performance, efficiency, and customer experience.